All right, so what we're going to look at here is two different functions, x squared and x cubed. And notice here we are multiplying the function by some number. So this is something that is on the outside of the function. So we keep talking about like our input and what happens on the outside. This is an outside change. So we're going to look at x squared first. I changed the numbers to 4 and to 0.25 just so you could see a bigger change than what's in your notes. So the first function then, if we graph, this is our parent function, x squared. This is going to be 4x squared. And this is 0.25x squared. Now, from Algebra 2, you guys probably learned this, is the graph is getting like narrower and wider. All right, we are going to go more into the mathematical language of what is happening here. Okay, and so this is the x squared graph. If we look at the x cubed graph, instead of 2 1/2, I used 6 and 0.1. So if I graph those, this is what it's going to look like. Oops, let's do one at a time. So this is x cubed, this is 6x cubed, and then we're going to have I think it was 0.1x cubed. Okay, so those are the three graphs. So you guys can see that there is some sort of change in how it's moving. All right. The tricky part with mathematically describing this is we have something where it looks like there's a change in an x and a change in y, right? Like we don't have the same points. So both of them look like they're changing, but it turns out there's only one value of your ordered pairs that are changing. So coming back here to look at this, we have x squared, and then I had put in 4x squared. All right, so I had put in these two values, and I want you guys to see on a table what is happening here. Okay, so for x squared, I know I have the points 1, 1, 2, 4, 3 what? 3, 9, and what would the next one be? 4, 16. Perfect. All right, so we have these points. All right, if I do 4x squared, okay, what's going to happen is when I plug in 1, what am I going to get for y? If I plug in 1 for x, so this is x, this is y. It's going to be 4, right? Because that's going to be 4 times 1, right? And if I plug in 2, then we're going to get 16. And if I plug in 3, 36. And if I plug in 4, yeah, 16 times 4. No, but that's important because that's what's happening. We are multiplying the y values by 4. And what this is causing is this was our y. This is now our new y. Okay? So how is that changing your graph? Vertically or horizontally? So if I have 1, right, and 2 and 3, 4, I still have those points there, right? But now I have, instead of going up 1, I'm going up 4. Instead of going up 4, I'm going up 16. So this is what it looks like here, right? So this was my original graph, and this is 4x squared. So what is changing in your points? Yeah, it's going to be vertical. It's the y value that's changing. So it's going to stretch it vertically. So it was here, but now it's stretching to 4. And here it's stretching to 16. And it's stretching that y value. It was 9, but now it's stretched all the way to 36. So what happens is if you have a value right in front, okay, right away that's going to be a vertical change of some sort. All right, because it's always going to change your y value. All right, when the number is more than 1, so 2, 3, 4, 5, 6, all right, is that going to stretch your y value or compress your y? That is going to stretch the y value. All right. So likewise, if I have 1/2, right, what do you think is going to happen to each y value? Good, yeah, it's gonna compress down. So we normally went up 1, but how far would we go up now? For 1/2, if I had this one, we'd only go up half that distance. So if I had 2 up 4, I'm now going over 2 up 2. And instead of over 4 up 16, I'm going over 4 up 8. So you're only going half of that much. So anytime you're between 0 and 1, that is going to be a vertical compression, because normally you would go up more, but we're compressing the y value by that amount. Okay, so that's a vertical compression. So we are getting away from the it's skinnier, it's wider. Like, we're not doing that. We're going to use mathematical language. All right. If the number is on the outside, that's changing y, and it's going to change it by that multiple. So y is going to be times 2. It's going to be times a half, and so on. Okay, the x values are not changing in these situations. Now, what's really tricky then, go ahead, go to the next page. Okay, so on the top of page 17, I want you guys to tell me, what is the difference between the bottom of 16 and the top of 17? Everything's inside the parentheses here. So now, notice that this is on the outside of my function, but all these values are in the input of the function. Like, we're plugging them into the function. All right? And what's tricky about it is the graphs actually do look somewhat similar. So let's take a look at the x cubed graph. And, and what I'm going to do is put in some parentheses here. We better just do 2. Oopsie daisies. Okay, so we're going to have these 3 graphs. Now I'm changing the input value, and I'm going to have you guys look at the graph. So there's x cubed, there's the quantity 2x cubed, and here's the quantity of 0.5x cubed. Okay. Now, if we were talking about, you know, if we're looking at this, the reason why it's so difficult when you're comparing the vertical and the horizontal is because, again, it looks like both points are changing, not just one set of points. Does that make sense? It's like, if this is our original graph, all the points are changing, but that's actually not the case. So what we're going to do is we're going to take a look here at x cubed. So we have obviously 0, 0, 1, 1, 2, what? 2, 8, 3, 27. 3 cubed is 27. All right. And now what we're going to look at is 2x quantity cubed. Okay. So here, all right, and I'm going to write this out purposely a different way. But here what I want to do is I want to make all the y values the same. Good. So I can plug in 0 and I would get 0. But to get 1, what happens if I plug in 1 here? You get 2, and what is 2 cubed? 8. So that's here now, because that's 1/8. Do you guys see that? So then it's like, well, how do I get this? So somebody mentioned, right? If I take half of 2, then I'm going to get a 1 in here, right? Does that make sense? If x is 1/2, and then I get 1 inside, so this value is going to be a half to get this 1. Make sense? Do you guys have any guesses what has to happen here?
Is it be 1 and 1/2?
Yes. So we're going to have to take half of this value, and if we plug in 3 halves times 2, so this is 2x cubed, is going to be 3 cubed, which is our 27. So if we have a 2 times x on the inside, what had to happen to all the x's to get the same y values? We had to take half of it. All right, so my next question to you then, what do you think would happen if I had 3x cubed? How would I get the same y values?
Would it be a whole, like, 1?
So we had a 2 here, right? And we had to take half of the x. So if we have a 3, what would we have to do to the x's? you'd have to do a third.
Oh.
Yeah. All right. So what I want you guys to think about this like too is remember when we have like x minus 5 cubed, all right? What direction did we move?
Was it the right 5?
This is right 5, right? We kind of had to do the opposite operation. We're actually adding 5 to all of our points, right? We did the opposite. This works the same way. Instead of multiplying by 3, what are you going to do to each x? You're going to divide by 3. So anytime you're working with an input value, you're always doing the opposite operation to the value on the inside. Make sense? So whether it's adding and subtracting or multiplying and dividing, you're going to do the opposite. Now let's go back to this though. If these were my x values, and by multiplying this 2x on the inside, my numbers got smaller, is that going to be a stretch of the x or a compression of the x? That's a compression, okay? So over here, anytime you have a number inside, that is going to change your graph horizontally. So just like when we had x minus 3 to x plus 3, right? That was a horizontal translation, all right? Anytime we're multiplying the input, that is also a horizontal change. But this time, if the number is larger, so like if we have a 2, 3, 4, we had decided that that's a horizontal compression. And then here, if we have 1/2, what is different than multiplying by half? What would you do instead?
You divide.
Right, and what is dividing by 1/2? It's the same as multiplying by 2. Good, right? So we would multiply by 2. If we had 1/3 x, we would multiply by 3, all right? So anytime you're dividing by a fraction, you're going to multiply by the reciprocal is what happens, okay? And as a result, then my x is going to, it's going to stretch. So anytime you have a number between 0 and 1, all right, because we're dividing by that number less than 1, it's going to cause our x value to be greater. So that is going to be a stretch, okay? Now this puts everything that we just talked about into one table for you. So I'm going to skip through that and go right to the practice. So let's take a look at this graph here. So we have our endpoints and our turning point here. And what we're going to do is we're going to find the y value of all those points. Okay, so -6, when x is -6, notice here, this is -2, -6. On the x-axis, we're going by 2's, but what are we going by on the y-axis? We're going by 1, so this is actually -1, +1, -3, -5, +3, and so on, okay? All right, so at -6, what is our y value?
It's 1. Wait, oh, just kidding,
-6
-6.
is
Oh, wait,
x.
-3.
Yeah,
Sorry.
no, you're good. And then I'm at -2. Y is
-3.
-3 again. What is it at 0? -5. And when x is 2, y is
-7.
-7. And when x is 6, y is
1.
1. Okay, so we're going to be trying to find the new x and the new y here. Okay. This 1/2, is that inside of our function? Is it part of our input, or is it on the outside? It's on the outside. Anytime you have a number on the outside, does that change your graph vertically or horizontally? Vertically. So this is going to be a vertical change. So vertical. And when you're on the outside, do we actually change by that multiple, or do we need to do the opposite? By the actual multiple. So is this going to be a compression or a stretch? This is going to be a 1/2. Good. So this is a vertical compression by a 1/2. All right, a vertical compression by a 1/2.
Oh, so it's not in the parentheses.
Because it's not inside. It's not part of the input. Good. And then is this inside or outside?
Inside.
Now that's the input. We're plugging it into our f of x function. It's being plugged in, all right? And because of that, is that horizontal or vertical?
Horizontal.
All right.
Compression.
So this is a horizontal. All right, it looks like a stretch, but we know horizontally that it's actually a compression by how much? By a third. All right, so we're going to compress it by a third. Okay, so what it was before, we're going to compress the x, and we're also going to compress the y. So we're going to take a look on our graph then. Because we're multiplying by 3 on the inside, and so you're always going to be dividing actually by that value. So anytime you're doing vertical, it's always opposite of the operation that we think it should be. So instead of multiplying, we divide. Instead of subtracting, we add. Instead of adding, we subtract. So horizontally, it's kind of always opposite of what it should be. So we have now, if I have the -6 for x, all right, if I'm multiplying by a third here, you're really dividing by 3. So what is -6 divided by 3? -2. This is going to be negative fraction. 2/3. This is going to be 0. This is positive 2/3, and this is 2. Okay, and then our new y, what are we doing to each y value? Yep, so we're going to multiply by half, which is dividing by 2. So this becomes and really, we just go through and divide everything by 2 here. Okay, so these are our new points. All right, these are the x, y's that go together. So now we can plot them. -2 is here. -3/2, we're going to go down 1.5. Plot a point. All right, -2/3, halfway is -1, so we're not going to go quite halfway to the left, all right, for -2/3. And then we're also down 3/2, so 1.5, and then a little less than halfway. Okay, when we're at 0, we have -5/2, so 0 down 2.5. 2/3 is a little less than halfway to the right. Okay, and then we're down 3.5. And then when x is 2, y is 1/2. Okay, and then you connect all those. Okay, so they're all connected. And then you guys can actually visually see x went from -6 to 6, right? Now it's only going from -2 to 2. All right, and then y down here was at -7 all the way up to 1, but now it's only going from -3.5 to half.
So does it mean that it like got smaller by 3 times?
Yeah, so this was a compression. Literally, we compressed it a third of the amount, and we compressed vertically half of the amount. Does that make sense?
Yeah.
So it's an actual compression both ways. Now this was nice because you can actually see a start and end with the functions. Like we had for the cubic function, our domain was all real numbers, right? And our range was all real numbers. So it's kind of hard to see a finite change in both directions, but here you can visually see compression, compression. Okie dokie.